Final example, two cars are approaching a right angle intersection on straight roads. The first one is coming from the north at a constant speed of 30 meters per second, while the second is from the east at a constant speed of 25 meters per second. If both cars are currently 200 meters from the intersection, how much time until they have a distance of 90 meters between them? Oi, right? This is like the classic nightmare word problem of like so many things here. What are we going to do? Well, we just start figuring out what is it telling us, then we'll work on the math. So first thing we do, we try to make a picture. So right angle intersection. So we know what it looks like, an intersection looks like on the street, right? Two streets intersect one another. We know that they came together at a right angle because it says right angle intersection. Great. They're on straight roads, so we're guaranteed the fact that straight lines come out of it, so this makes sense. The first one is coming from the north. Well, let's put north as being this way. So this car is up here. It's coming from the north at a constant speed of 30 meters per second. So it's going down 30 meters per second. Where is it right now? We know it is 200 meters away at the start. What about the other one? The other one is coming from the east, so east will be over here, and it's going at 25 meters per second. How far away is it? They're both cars, so we figured out the 200 meters to get the first one. Both cars, currently 200 meters, so 200 here as well. How much time until they have a distance of 90 meters between them? So we also want to be able to introduce so I guess the other thing we have to figure out is what does it mean for distance between them? So if we've got a point here and a point here, then the distance is just the distance between those 2 points, right? But we don't have any information about the distance between them, right? We're not told how far away they are. But we are told how far they are from this intersection in the middle, right? So this, if we've got here is x and here is y, oh, hey, look, we can use the Pythagorean Theorem, x squared plus y squared equals d squared. Great, so we've got a way of relating these two things. But if we're just frozen at 200, 200 squared plus 200 squared equals distance squared, then we're going to get something that's never going to be 90, right? Because we're just looking at a single snapshot in time. So we also have to have a way of their movement, their motion affecting this. So they start off at 200 away, but then they start to get closer and closer to that intersection. So it's going to be 200 minus 30 times t, because it's going to be as they get closer to the intersection, as more time goes on, more of their distance from the intersection will disappear. So 200 minus 30t. And then the other one is 200 minus 25t. Because the red one, the north car, is coming at 30 meters per second. So for every second that goes by, it will have moved 30 meters towards the intersection. So it will be 200 minus 30t. And the blue car, the east car, will be 200 minus 25t. Because for every second, it moves 25 meters towards the intersection. 200 less 25 meters. OK, so at this point, we've got a real understanding of what's going on. We can now put this d in here, and we can connect all of these ideas. So we've got 200 minus 30t is what describes the red car, our north car, and 200 minus 25t is what describes the east car, our blue car. And we're looking for when is the distance equal to 90. So remember, we had x squared plus y squared equals d squared off of the fact that, this is just a nice, normal Pythagorean triangle. We can use the Pythagorean theorem here. Square of the two sides is equal to the square of the hypotenuse. So we've got 90 squared equals quantity, 200 minus 30t squared, our red car, our north car, plus 200 minus 25t squared, our east car, our blue car. Great, and now we're trying to solve this, figure out when is t going to make this true. At what t will that equation there be true? So we just start working it out. Now this is going to get pretty big pretty fast because we've got big numbers, but luckily we've got access to calculators in this world. So 90 squared, plug that in, that comes out as 8100. 200 times 200 becomes 40,000. Minus 30t, 200 times negative 30t, plus negative 30t times 200. 200 times negative 30t is negative 6,000, but we have to double that, so it's minus 12,000t, minus 30t times minus 30t, plus 900t squared. The next one, so plus 40,000 again for the other portion. 200 times negative 25 becomes minus 5,000, but then we also have to have negative 25 times 200 again the other way, so it's negative 5,000 doubled, so minus 10,000t times plus negative 25 times negative 25, so plus 625t t squared. All right, we simplify this, get this into, this looks like something that could eventually turn into a quadratic, right? So we go, time to use the quadratic formula. So we need to get into that form. We'll subtract 8100 over. So 0 equals, so minus 8100, minus 8100 over here. So we look 625t squared plus 900t squared. We get 1525t squared. Next, minus 10,000t, minus 12,000t, minus 22,000t. 40,000, 40,000, minus 8,100, plus 71,900. Oi! But we're in a position where we can now use the quadratic formula. Once again, it's a good thing that we have calculators, otherwise this would be really difficult, but we can use the quadratic formula now. So t equals negative b, so negative 22,000, so 22,000 plus or minus the square root of b squared. So 22,000 squared, we'll drop the negative sign just because it's going to get squared anyway. 22,000 squared minus 4 times 1525 times 71,900. At this step, we might toss those parts in, just the part underneath the square root, use the discriminant, make sure there is an answer. It will turn out that there is an answer, so we'll just keep going. And that's going to be divided by 2 times 1,525. I won't work this all out here. I'm going to trust the fact that you can do the two different versions. Remember, there is a plus version, and then there's a minus version. So we do both of the versions, and we will wind up getting t equals 5.004 seconds and 9.423 seconds. So in the last one, the problem with the falling rock, where he threw the rock down the cliff, there was only one answer that was true out of the two things that came out of it. But what about this one? Is one of them wrong and the other one right? Is it only possible for one of them to happen first? Well, if that's the case, if we're only looking for what is the time, the immediate time, the soonest time when they are 90 meters away from each other, then it's 5.004 seconds. However, if we think about what's going on, let's try to visualize this, right? So we've got car in the north, car in the east. They start off very far away from one another. But as they get closer and closer to one another, at some point their distance is going to, right, this one's going faster, this one's going slower, but they're going to pass so that their distance is close enough for it to be like ding, 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 5.004 seconds. They are now 90 meters away. Now they pass and they wind up being very close briefly, but then they keep going, and at some point on the reverse side, their distance begins to grow now after they pass the intersection. So they actually start to get farther away. So after they pass the intersection, eventually it's going to be ding, 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 ding. They are now 90 meters away from one another once again at 9.423 seconds. And then if they keep going on and on and on, they'll never wind up being 90 meters away from each other. But this is the first time they are 90 meters away, and then this is the second time. Now, it's quite likely that a question phrased in this way would only be asking for the first one, but we are actually able to find out both of the times that they are 90 meters away, assuming they maintain constant speeds and straight roads. Pretty cool. All right, hope you've got a good sense of how to complete the square and how important and useful the quadratic formula can be. Make sure you memorize it. I know I hate memorizing things too, but it winds up coming up so often you really have to have it memorized. Negative b plus or minus square root b squared minus 4ac all over 2a. Make sure you get that one burned into your memory because it will show up a lot. And we'll see you later next time. We'll talk more about the general nature of quadratics and parabolas and see how what we just did in this lesson will wind up connecting to that one as well. See you at Educator.com later. Bye.